Let's go live.
Okay. Okay. Hopefully they can get us now. Yeah, we're live. Okay. Everybody, welcome. Let's open the parentheses for another LispNYC event. I'm your host, Arthur Smiles. This is LispNYC, where we talk about Lisp, we talk about AI, we talk about computer science topics, we talk about math. As we like to say, we like to think outside the parentheses. So with that, let me introduce our speaker tonight. Sorry, my brain's freezing. Okay. Fari here is a big-time Lisp hacker. You probably, I think the single most biggest project that everyone's used in the Common Lisp community is, I think it's called ADSL.
ASDF.
ASDF. Sorry, I always get it wrong. Anyways,
wait, don't you have a QWERTY keyboard?
Any kind of package management in Common Lisp, you've used the software at least for the last 10 years. I think now the new guy's running it. In the meantime, he's also given many talks all over the place, including a couple of talks with us. And now he's going to give a third talk about prototype programming. So with that, Fari, take it over.
Okay, I think it's actually my fourth talk with you or something like that, but that doesn't matter. Can you see my screen or not? No?
Yes.
Yes? Yes, excellent.
By the way, Arthur,
yes.
Something you might want to think about is it possible to record just what we see on the screen here and not the whole thumbnail gallery?
Actually, I fixed that problem, so.
Okay, cool.
Yeah,
excellent.
It's showing the whole screen. Yeah.
So I want to discuss something that is called object-oriented programming and the essence of object-oriented programming. Like, what is the essence of object-oriented programming? To me, object-oriented programming, what makes it good and interesting is that you can write your code in small increments. The idea is that when you have a piece of code, you want to write it once and only once and not have to repeat it all over the place. Basically, you don't want to ever have a design pattern. To me, every design pattern, I think Richie said it well, design patterns mean I have run out of language. And object-oriented programming is all about not running out of language, at least in one dimension, which is sharing code and not having to rewrite the same piece of code multiple times. And so we want to write code once, and incrementally, if I'm going to write what is a balanced tree, I want to write it only once. If I want to write what is whatever it is, I want to write it only once. And then everyone has used object-oriented programs in one way or the other. If you use Common Lisp, you use a class. If you use Java, you use Java classes or whatever. Everyone is familiar with at least Java or C++ or Scala or what have you. Who else has never used in this room an object-oriented programming language? Please. Okay, no one? Okay, so you're already, you've all used it once, way. But what is the essence of it? Like, how can I distill the essence of what's interesting and good about it? And that's what I'm going to discuss. So I have a 98-character definition of object-oriented programming here. This is two functions, a function that instantiate a prototype and a function that does inheritance of prototype. And my claim is that these two functions are the essence of object-oriented programming, or at least of the inheritance mechanism underlying object-oriented programming. And I didn't invent that. I claim I lay no claim of invention. I found it already done, for instance, in Nix. If you know the programming language Nix, that is the programming language to configure NixOS. Nix itself, 1 year before Nix, it was done this way, but under the hood in a language called JSONet. And JSONet is from 2014. And if you go way back in time, this model is still essentially isomorphic to what was in programming language T. T is one of the first scheme systems, like let's do a serious system written in scheme. So it's T, 1982. And if you want to go even further, there was something called ThingLab written in Smalltalk that you can check out online. And it's from 1979. I think in the Smalltalk community, it's such that you can still run your images from 1979 or something like that, or code that is essentially the same code in 1979. You can still run it. And that's it. And if you go on the page for prototype-based programming, they will tell, oh, the first language is Self. But Self is from 87. Almost 10 years before there was ThingLab, and 5 years before there was T. There was also before Self, there was something called Object Lisp in 85 that had a prototype object system. ABCL from 86 had something essentially equivalent. No, Self is not the first one. And of course, the most famous prototype. What is the most famous prototype programming language? It is called JavaScript. And so if you use JavaScript, you may have used the prototypes. They are particularly ugly and not well-designed JavaScript. And lots of people say, oh, prototype object programming sucks. Look how it's horrible and hackish and whatever in JavaScript. Well, yes, it is hackish and horrible in JavaScript, but that's not because prototype objects in general are horrible and hackish. It's because JavaScript is horrible and hackish. But if you look at the original papers from, for instance, here's a good description of the T object system. Where is it? It's a paper from '89 by Norman Adams and Jonathan Rees. I don't know what its number as an AI memo, but it's from March 1989. It's perfectly describes the object system in T, including how you can implement it in a totally portable way in Scheme, or mostly portable way since you need a type, a structure type, or something for your instances. Okay, so let's now look at. It's good to have a 98 character definition, but what does it mean? So let's look at the modern approach. What does it look like in a modern language? Let's look at JSONet. You can look more about JSONet, jsnet.org. It's a very interesting language to study. I would not recommend using it, even for its purported goal of configuration. I believe that, well, there are many things I like and don't like about it, but I think as a language it's very well, but all the tooling makes it not the best. I would rather use prototypes in Scheme and in Gerbil Scheme that I use. But as an illustration of the concept, you know, it has a very blobby syntax that everyone will understand. And so what do you think? Let's take Arthur. You're the host. You will be my victim of choice unless you designate someone else to be victim of choice. What do you think this program does? Or what do you think is the output, the JSON output of this program?
1 second. I lost your screen there. Okay. Actually, I know absolutely nothing about JSONnet. And
Perfect.
When you talk mentioned, I went over there and I was like, okay, this is going to take me a while to figure out what you meant by how this is a prototype system. So
okay, so what do you think this does?
I mean, I would say that person 2 is basically has everything that person 1 has, but the name is Bob instead.
Yes, and what will the welcome for person 2 be?
Hello, Bob.
Hello, Bob. It will be indeed hello, Bob.
Yeah.
When you override the computations. Mm-hmm. And you only compute the values at the end after all the overrides have been computed. So when I say person 2 is a specialization of person 1, this means like take person 1 and override this. And when I'm going to override the name, it will override the computation for the name. And when you're going to ask what is the welcome for Bob, it will then use the computation for name in Bob. So this is an example of late binding. This will do late binding of name. This is the name of the final self at the time you instantiate. And of course, this self is a self of person one, and this self refers to this entire object. So, or if you specialize this, it will refer to the self of whichever object is this plus whatever you extend it with. Okay, so what does this look like in this thing? This local thing is a let. It's just let it local. I suppose it's inspired by Python or whatever. But basically, it means let's define a function, a lexical scope function with a argument named Alice, and we'll put the name there, and the welcome will be that, and the person. So it's functional programming. And one particular thing is that this is lazy, dynamically typed, pure functional programming. And let's do the same kind of things in scheme. So Control X9 for me starts a new Gerbil scheme. So it's a Gerbil scheme personalized a bit to have my layer on top, which is still glow, but we can't forget that it's Gerbil scheme. So if I do, what's the name of the function? I don't remember. So let's go to Gerbil/util/versioning, something called software version. Okay, let's go software version. Okay, but that's not, maybe I should do the full version, software version. Where do I get that? Show version complete T. Okay, so show version complete (T). Okay, so it's Glow, Gerbil Ethereum, Gerbil Persist, Gerbil Poo, Gerbil Crypto, Gerbil Utils, Gerbil Gambit. So it's a whole layer of software, and the layer that interests us here is called Gerbil Poo. Version 0.035. Okay, so I can import a lot of things this way, and I can write something. What did we want to do? Person one. Person one will be, what will person one be? Let's go back there. The person one will be name Alice, and the second thing, welcome. Welcome will be string append or format. Well, let's see, format is defined. Format hello till A. Let's try that. And name. Let's try that. Let's try that first. Just this thing. Does that work? That's a poo object. And so let's look at the name of it. Name is Alice. And let's use at the welcome of it. Ta-da. Hello, Alice. Now, if I specialize that with Bob, so let's do something like person one. Person one is this. Wait, is this? Do I need to indent more or anything? Okay, let's do that. And person two will be about the same thing. Person two will be, the name will be Bob. But I want to extend the person one. Okay, so I think I have a syntax for that, which is something like, I think it's that. Person one. I will inherit from person one. I think that's the syntax, right? And let's do that. Okay, and let's compute the name. Let's look at person two in it and the name. Okay, the name is this, and the welcome is no such slot. I must have done something wrong. What's the syntax for that? Let me look at the syntax for it, or put test. Tests are a great way to do a syntax. Ooh, it's colon, colon. Okay, so there's magic syntax there. It was colon, yeah, oops. Anyway, that's just syntax. So let's look at this. It says, hello, Bob. Okay, so I can define objects and override and inherit and do things like that. And so the syntax is that I can specify a slot, and in this slot I will associate a computation, and this computation can either refer to other slots, like the name, or it can refer to super. I will show you how we can refer to inherited computations for the slot from the super object that we inherit from, and etc. Okay, let's.
I have a quick question.
Yes.
The double colon, is that shorthand for the inherit?
Yeah, it's a magic keyword. We'll see later what all that it means, but it's a magic keyword that says yes. Here I'm going to this is a special specification of inheritance, and this is a this keyword basically, or the this. And person one, we could have a list of person one and person 0 or whatever. This is a list of things that I'm going to inherit from, and then I can have an extra list of slots, such as slot 1, slot 2, and that I can then refer to in the body in the computations.
Okay, cool.
That will be the syntax, and we'll see examples for that. But for now, I want to show you. What did I want to show you? I want to show you more examples with next. Ooh, next. Do I have something .next here? Next, an overlay. So in next, you have this system where you can basically define a mixin. This is an overlay that takes the entire next configuration, and then I'm going to modify it. So here I'm going to take the entire Nix configuration, and I'm going to modify it so that it has an extra package called Moonglow. And this is a mixin, so I can use a super objects. I can use all the object-oriented machinery to do whatever I want in defining this thing. And say, oh, how do you do that in Nix? Well, Nix, unlike JSONet, so JSONet you can read the specification, it's a great language to study. The object system is built in. In Nix, the object system is defined in this 10 lines of code. So here is one line of code that define a fixed point. Here is not a fixed point, but then you remember the unfixed prototype. So this is exactly what we're going to do with objects. You do the fixed point to get the values, the fields, and you remember the unfixed point prototype so that you can compose and do your computations and your inheritance. So you want to remember the computations, that's the unfixed, and you want to do the fixed point to get your actual values. And this all works great because the computation is lazy. So even though you may not have a fixed point to a particular mixin, the object is still accepted because you will not actually compute the values. And the object is still useful. And then when you compose, at the end, you get the object that you want after you compose all those mixins. And then you will be able to compute the values. But I'll show you examples of mixins that are useful this way. But basically, with all these, this is almost the entire object system. Like in 1, 2, here how many lines? 8, no 7. So we're at 9 lines of code. 9 lines of code plus this is the inheritance function. So like we're at 10 lines of code, and 10 plus 5, 15 lines of code, and 16 lines of code, and 20 lines of code. There's 20 lines of, the entire object system is these 20 lines of code.
Wow.
In a pure dynamically typed functional language. This is the entire object system. So if I look at the essence of it, that's how I get those 98 characters of scheme, and we can look at it a bit expanded. So okay, if I if it looks like that, okay, it's 98 characters, but let's explain a bit more. Make instance, that's how you instantiate a prototype. So a prototype will be a function that will take your the final object and the base object as a argument, and will return the. Wait, no. A prototype is a function that takes a base a final object from the base object and returns the final object. And so the final object is the actual final object is computed by doing the fixed point. So you give the thing of which to get the fixed point as first argument, and the bottom object as the second argument, and that's your prototype. And then to instantiate a prototype, well, you take the fixed point. So the prototype is the function of which you want to take the fixed point. The bottom is the bottom object of your computation, the starting point of your recursion of your fixed point. And then you compute this fixed point and you return the fixed point. So that means that in this model, which is exactly or almost exactly the same model as you have in T, in the programming language C from 1982, to compute the fixed point is that. Your fixed point is you bind self to calling the prototype with essentially self and bottom. And this function is here, the lambda a apply self a. Basically, this is self, but protected by a lambda. And you need that in Scheme because Scheme is not a lazy language. So you can't just write self. You want to protect the self with this lambda so that you have a handle on it. If Scheme were a lazy language, such as Nix or JSONet or Haskell, you would not need this lambda. You could write self here, but because Scheme is applicative, you need to protect. Yep. Otherwise, this will bottom. This will self is prototype of self bottom. This would not work. Yeah. So basically, self is a fixed point of prototype self bottom. You return that. And inheritance is even simpler, and it's one line of code in Nix, and here I put it in 2 lines to make it slightly more readable. To inherit, if I have 2 prototypes, this and parent, and I want to compute a new prototype, which is a composition of this prototype, this and parent, and the fixed point I will get itself, and the object, the bottom or super object will be called super. Well, I apply this to self because this must be called with self, and the bottom object to this that I will provide to this is parent of self super, and parent will be given the same self. So here is the same self, but the changed super. So the supers are chained, but the self is the same. It will be a fixed point for everyone. Everyone will be able to access the fields of the final object. So that's how your computations can access the field of the final object of the fixed point, and yet your computations can also access the super method, the inherited method. And that's it. That's the essence of inheritance and computations in essentially 2 functions, 2 lines of code. Okay, so what is a NOP? What is a trivial prototype that does nothing? It's a prototype that just, you give it self and super, it ignores self, it returns the super. This prototype does nothing. This is a NOP. This is the null prototype, if you want. This is prototype that does nothing. Oh, if you have a list of prototype and you want to inherit, well, you do a right fold of inherit on all those prototypes. You could also do a fold left, but I think it might be less efficient in some ways. If I want a button object that ensures that things fail, you can have the error function as bottom. And now, if you want to instantiate a list of prototypes, all you can do is a make instance of reducing this list of prototypes with the bottom object as the bottom object defined here as and this is all. You already have object-oriented programming. You see, oh, but how do I deal with the field? Like my prototypes or prototype for functions. What is an object? Well, you say, well, an object will be a function from symbol to value, just like in good old T from 1982. So let's pass these assertion functions. Okay, here's how you define a field. here's a function that returns a prototype that defines just one field. Let's have a field defined by a keyword k, to which we'll associate a value v, and have this field. Well, I take self and super as my extra parameters and well, I don't remember what MSG is. Oh yes, and then you will take as a parameter the message that you take to the object. So the field is defined, the mixin is defined by the keyword and the value. Then the object is defined by, well, the field applied to self and super, the field plus all the things that will be all the combination, but applied to self and super. And this defines an object. And to this object, you pass a message, which is MSG. So lots of querying around. And what is the behavior is that if the message I receive is this keyword, then I return v, the value. Otherwise, I return, I pass the message to the super prototype.
Yeah.
And you can see that indeed, if I compute the instance of field foo 0 foo, it will return 0. And if I have an object that is an instance of field x1 and field y2, guess what? It's an object that if you pass it x, it returns 1, and if you pass it y, it returns 2, and if you pass it anything else, it will error out. Here's an interesting... I
got a quick question about fields.
Yes, yes.
Are fields also prototypes?
Yes, the field is a prototype. Yes, I mean, this thing returns a prototype, and this thing instantiates, basically, get an instance from this list of prototypes. So basically, it will change this prototype. I will have a prototype that inherits from field, the first one and the second one, and then I compute the fixed point. It's an instance, and that's my object. And my object is an object that when you pass it x, it returns 1, and you pass it y, it returns 2. It's pretty straightforward. Here's a mixin that you give it a self. Okay, self and super is just the plumbing. You pass it a message, and if this message is first, I compute a private value z, which will be computed by adding the x value of self and the y value of self multiplied by the I, which is a complex root of -1. And you do that. And now if I receive the message rho, I will give the magnitude of z. If I receive theta, I will give the angle of z. And otherwise, I pass the message to my super prototype. And you see that here, for the sake of lazy computation, I do not yet compute, but I could, I suppose. But for the sake of lazy computation, I wait until one is called. And I could actually make it, if I wanted to cache it, I would make it a lazy instead of, I would do lazy here instead of lambda, and I would use force instead of yes, that would be another way to do it. Let's leave it at that. And now this prototype commute. Yes, this particular prototype commute. If I put y x first and y last or whatever, it still works because I'm calling self. I'm not calling super here. I'm not calling super the x of super. I'm calling the x of self, which means that I can mix and match all these mixins and it will still work. So as you see, instead of having functions from symbols to values, I could have functions from say reals to reals. I could say, oh, here's a function. So what is just k? Just k is a function that is a just k is a, how do you call that in it's a k combinator.
It's a monad, right?
No, it's not a monad. It's a k combinator. It's a combinator that always okay. So
It
here's a
always
prototype.
returns k. It's just a constant function, I guess.
Yes, constant function, yes. So here's a prototype for the constant function lambda xx. This function, this is a prototype that will always return the function lambda xx. And if I instantiate this prototype, I will get a function that returns, I will get lambda xx. Here's a prototype for even functions. If you remember, an even function is f of minus x is f the same as f of x. So here's a prototype that says, oh, if x is a negative, I just need to compute self for the positive for minus x. Otherwise, I could call super with x. And here's a cube function that computes the cube of what the super returns. So let's see what the super returns and return the cube of that. And you can compute abs of x3. So the function that computes the magnitude of the cube of x can be done this way, for instance. So you don't have to have functions from symbol to values. You could have functions from A to B, where A is an arbitrary type and B an arbitrary type. Oh, that's my favorite. One of my favorite macros, nest macros. I wrote a lot about the nest macros. Go read my live journal post on the nest macro. Anyway, that nest macro means I can just host the things in the next thing. So for instance,
could we go back to the previous section, because I have a question?
Yes.
So you have this instance is
the instance function. Yes, it composes all the mixins. You pass it and mix.
So it creates a prototype out of all those mixins, right?
And then it extensions them with make instance. Then it makes the mixing point.
My question is how did it know? I think you have depending on the number, it's going to run one of those things, right? And basically, you do a type check. Is that what's going on?
It will run them from left to right, and if it hits the bottom, it will error route. So so the
even one is going to run, so it's going to go to the super, which is cube, and that's why it's 27.
Yes. So and cube goes to identity, and identity returns the same 3.
Effectively, this is just it's like a different way of expressing a position function.
Yeah.
Yes.
Right? You're composing a function that makes a function even with a function that takes the cube of a function with the identity function.
Yes.
But this is using an object-oriented way of representing those concepts.
Yes. And obviously, this is not super duper. This particular example is not meant to be so much useful. It's meant to It's meant to illustrate that mixins and composition is indeed a very general concept that can apply to objects, that can apply to functions from real to real, that can apply to anything. It's not specific to associating a value to a field. It's not just for records. Prototypes and mixins are not just for records. They're for any kind of function or
it doesn't just associate a name with a value. It can associate anything a value with a value.
Yeah, exactly. You could have So it's yes. Here is a function to memorize values, make counters. I don't remember what memory. Oh yes, I do this memorization because one of the things that makes this pure functional thing work is caching and memorization. So I use memorization to have a poor man's implementation of lazy evaluation, basically. And I don't think so. Here I'm implementing the more recordy thing, but this is not how I use it in practice. So this file is about basically showing what the essence of it. This is not an efficient implementation. This is not supposed to be the thing you use in practice. It's supposed to be the thing that shows you the essence of the semantics of it. So the semantics of it is this 98 character Quan. This is the essence of object oriented programming.
Yeah.
Okay. What did I want to discuss next in this thing? Oh, yes. Trivial unique prototyping, linearized scheme, prototyping scheme, model T. Poo. Oh, yes. Now let's look at Poo and what it does and how it works. So here is Poo, and the essence of it fits in less than 300 lines. And in these 300 lines, I have a lot of utility functions and etc. So I'm not at 20 lines, sorry. And one of the reasons I'm not at 20 lines is that I have to implement my own laziness caching scheme. I have to implement my own records or whatever. And I implement a lot of syntax to make it very nice. So for instance, the instantiate function is also very short. It's the way I represent things is with a list of prototypes and an instance cache. So a structure Poo has two fields, list of prototypes and the instance, which would be a hash table. And the way I initialize it is initially the instance is not even, there's no even hash table. I just have a hash f. And my prototypes is given at initialization time. To instantiate a Poo object, if it's not initialized yet, then I'm going to replace hash f by this empty hash table. And in the future, I will probably call a special .init method. If it's already initialized, instantiated, I don't need to create this hash table. Otherwise, we'll have an error if it's not a Poo that you pass to me. Who can have special behavior when the slot is not found. For now, it's not very configurable. It's just error no such slot. But you can imagine how you could have more general purpose things there. To reference a slot, you give let's consider an object Poo. Let's consider the slot of a given name or value, and a base computation function, which is by default no such slot, but you can provide a better behavior than that. And as you can suppose, I'm going to extract the prototype of the instance using this match special form. And then I will hash incure, that is, I will look at the instance hash table, and I would look if the slot is defined. If the slot is defined, I just return what's in it. If it's not returned, here's a function that will, so cut is the kind of a delayed evaluation macro, and basically create a function that in this case has no argument and calls compute slot with Poo prototype slot and base. And compute slot, the thing does what suppose it does. That is, it will, if there are no prototypes, it will call the base function, which by default is, once again, it's no such slot. And if it is provided a prototype, well, is there a method for that slot in that prototype? If yes, call it with the object self, the self object Poo, with a list of super prototypes and with a base function, otherwise recurse, etc. So this is all the same principle, just optimized for objects with slots, and the rest is append prototypes is just flattening a list of or a recursive list of prototypes, and everything else is very straightforward. And then I have the syntax, the magic syntax, which is called .o, and I use lots of magic syntax to make things nice. So if you look at poo.md, let's look at all the nice syntax that I may have. So the general case looks like this. I have a .o, which can be, if you import the correct, if you import clan/poo/brace, you can simplify .o by brace. And you give it optionally a specification of self and super and extra slots, and then your slot definitions. And so what I think it's better to look at the examples in poo test. So a simple poo is .o of x1, y2. This is a field of 1 and 2, and it must be a poo. And if you define foo as a poo of x and 1, that will do the thing. You can also do an unpure thing here and override in a side effect a field in a poo. Not something I recommend, but you can do it if you need it. You have a syntax. What are interesting syntax? And mix two things. So here I have the famous blue point. Where is the blue point? Here's a mixing that just says the color is blue, and here's a point that just x3, y4, and I can mix them by being, I can make these two mixins to have blue, a blue point. And indeed, it's x will be 3, xy will be 4, its color will be blue, and I think I need to switch rooms. Let's switch rooms. Ta-da! Switcheroo! Okay. Can you still hear me?
Yeah.
Can you still see my screen? Can you still see me?
Yeah.
Okay. I can define a complex object like this. A complex mixin that computes computes x plus iy being a field named x plus iy that will be the sum of x and I times y. And here is a mixin for polar coordinates. And if I compute the row of my polar coordinates for my point defined above, I will get 5 because the magnitude of 3 plus 4i is 5. If you remember the Pythagorean theorem. Okay, this is nice, but let's go to the next part of my talk, which is, what do I do with this? Well, the obvious thing we want to do is classes or type classes or more traditional object-oriented programming. I told you that prototype objects are more expressive than class-based object-oriented programming. Why? Because you can trivially implement classes in terms of prototypes, and actually not only you can, but it's something that you usually do because it's useful in lots of cases. But you also have prototypes that that are not elements of classes, and that's what makes it more useful, because sometimes you don't want a class. So what are examples where I want a class? So here I think I have a number, for instance. I have a class descriptor for numbers in general, and numbers in general would be, a number is a type, so somewhere type is defined. What is type? I think it's in mop. So type. A type is something that has a sex that describes the type, and it has an element which is a function from any to bool, and the validator is a function that returns a thing of that type. The at here is basically myself, but usually instead of typing self, I type at. And I like my functions to be from right to left, because the functional syntax scheme is from the right to left. So I like to put my functional type arrows from right to left. And I will blame MLers for contravariant, that their arguments, whatever the syntax is from right to left, whether type are from left to right. That's very confusing to me. If I wanted type from left to right, I would use force or another programming language where syntax is from left to right. So validate take any object and returns an object of the proper type, or else errors out. And optionally, it takes a list of any. And why is it list of any? Which will give you a context for the error, so your error message can have a context when you validate. And finally, I have a function toSexp that takes an object of I don't have a. I should write a type for that. The type of toSexp is a sexp from an object of type alpha, or of at, or from an object of the thing. Okay, so what is a number? A number is a number, and if you are an element of number, you it, and it has all these things. And the real is a number, but here I will override the sexp as being real, the element as being a real. Add, submul, div is the same, but the comparer, I can have a comparer function number comparer, because real numbers can be compared. Arbitrary numbers can be complex and that cannot be compared, but real numbers can be compared. I can compute the sign of a number. I can do all kinds of stuff this way. What is rational? A rational is a real that is also can be described as a pair of integer and nat, and then I can get a nat pair from a rational, and a rational from a pair. Why should be? It's not a nat pair. It's more of a pair here. Okay. Anyway, and you can marshal it, and I can unmarshal it, and I can convert it to a bytes array, or I can get it from bytes. This is, see, there are bugs here.
So one of the cool things about your project is that you can even have these parts like 2 bytes or like serialized or JSON as mixins, right?
Yes, everything is mixins now, and so mixins are very useful to describe types. And actually, you can, if you step back, you can think, oh, what are these type descriptors? Basically, a class is a type descriptor, and a type class is a type descriptor, but it can be a class is a type descriptor that you will shove into an object in a special field, which will be in C++ they call that the table, the V table, basically. And I can describe my V tables as mixins, and that's my thing. And if you saw my other presentation on Lisp interface library, an interface passing style, these mixins basically help you define very easily the thing that will pass in interface passing style as the descriptor for what's happening. So this is so I invite you to read to view or read my article or view the presentation on the interface passing style. And I think why is it? Yes, that's why it was not working with our bugs, because this was never uncommented. Okay. And an integer is a specific rational, but the element here is the element function, and you have additional functions, etc., etc. The nat is a specific integer, but you cannot go under 0. And so an integer range, you can define all kinds of things like this. Then what can you define except for numbers? You can define types such as a record, or a type or false, or maybe, or a pair, a union of 2 types, an enum, and exactly a type that must be exactly something. Bottom or top. This is the bottom type. Is you know everything about nothing. So there is no element in that type, and you know everything about it, which is that it doesn't exist. And the top type is the opposite, is a type for when you know nothing about everything. Everything is top, but you really know nothing about it. There are 2 very basic types. I have types or, like this is like basically one A or B, like the union of two types. There are many types that you can do, and you only need to describe the additional method compared to what you want, and it's very easy to define mixins, etc. What can I show? And I use that everywhere. So, for instance, type null is exactly the null object. Type false is exactly the false object. Type true is exactly the true object. Type unit is exactly void. So in Gambit scheme and there in Gerbil scheme, there is a void object. I don't know if it's in R, N, or S these days, but that basically is the object you return to computation.
I think you could simulate it with just values with no.
Yes, so
actually you can simulate it. Actually, perfect unit is just the empty list.
Equal void values false. That's false in Gambit scheme.
Actually, values with no values. That would pretty much right. But
you have choices. So
unit actually, because I don't know how schemes determine that.
I mean, any object could be used as unit.
But,
This is just the one I use in Gerbil scheme.
Yeah, I think the poor man's unit is always the null type. Right, a list with no.
So values with no arguments is never going to be an object.
Yeah, it would be in Gambit scheme. It would be an object actually. Gambit. So
technically, it is unit because you can call it values, right? With a lambda with no arguments, which would be the unit would be the unit value in functions. Anyway. So
this is not portable. This is not portable to every scheme. Yes, this is not portable to every scheme. It's just that I made a choice of saying my canonical unit is this particular object. So that's what it is. Okay, I have records, I have unions, I can have anything. And let's look, for instance, in my Ethereum types. When I do Ethereum types, I will import with poo. So I'm importing things from the general purpose poo thing. For instance, I'm guaranteeing importing the general bool string and symbol, and nat and uint and inset from. I import all that from poo, and other things, plenty of things prefixed with poo. And then I can override things. I say, oh, my nat. Well, when I'm going to print them in JSON, I'm going to print them the Ethereum way. And when I'm going to print my integers, I'm going to print them the Ethereum way. And when I'm going to do additional things, so here's a mixin where I inherit from the regular uint things and I add Ethereum specific behavior to it. Or for bytes, here Ethereum specific behavior to it, so I can do things in nice ways. And if you see it somewhere, I inherit from foo.bytes n. No, that doesn't help. So I have plenty of behavior. I can specialize my functions, basically my prototypes. Other things I can do with my prototypes is trees. Oh, I have, let's look at trees. So here is trees. And there's 1,000 lines, so I'm not going to go all over it. But trees are very nice data structure, pure big endian Patricia trees. And you should try to do the same thing in Go. I think in Gerbil, in Go Ethereum, they plant trees which have like maybe half of the functionality that I have, and it takes them 10,000 lines of code in Go. And by using functional programming and prototypes, I can do everything in 1,000 lines of code only. Okay, and maybe I'm using a table here, so you may want to add this 200 lines here. But really, and in there, I also have trees used as a sets rather than as a map from a finite map from A to B. So a tree, I think they're called tries or Patricia trees. They're basically functions from natural integers to whatever you want. And there are ways to extend them very easily from relative integers to whatever you want by saying, oh, well, this positive is this, this negative is that. But it has lots of good properties. It's deterministic. It's there's a canonical representation for any tree, and it's recommended. It has types everywhere. So these types are not mostly not enforced. Do I enforce some types? Some types I enforce or I enforce during debugging, and I use validate to validate things. But I don't see any validation here except when really needed. So, by composing this basically base tables so basically if you give me these 6 methods, I can deduce all the other methods about a pure table. Of course, some of the methods I derive might not be super efficient, so you will want to make them more efficient. But at the bottom of it, I only need to define these 6 base accessors to define a finite table from A to B, from key to value. And of course, the types key and value. And everything else can be deduced. But for my tree, I use lots of clever techniques to make it efficient and tree specific, of course. But what is even more interesting is when I want to persist those trees. So I go Gerbil persist / where's tree? Merkle trees. Merkle tree. And here I can persist everything in 70 lines of code only by using prototypes. So my tree uses, for instance, a digest context. It uses a wrapper mixin or prototype, and by just changing the wrapper prototype from something that is identity function to something that will persist the thing properly, I can persist all my trees, and it's just 70 lines of additional code. So this is very powerful. So back when I was programming in OCaml, I would use a lot of what they call functors and modules. And as compared to prototypes or program with modules, is that you have no notion of inheritance, so no notion of easy composition of modules. So if you want to simulate inheritance the hard way, you can, but it's extremely heavy syntax-wise, and it's not generic, etc. And in Scheme, where you don't have the benefits of static typing, but you don't also have all the problem of static typing, I can use prototypes everywhere, and instead of having modules and functors, I have prototypes and functions that return prototypes. It just works perfectly, and this takes like at least half the code that I was using in OCaml, and it's so much nicer and so much more powerful. It was also hard to debug at some point when I didn't have types, but then I discovered a lot of other bugs that were still in my OCaml version, because I thought in OCaml, oh, if the types pass, it's passing. Not so when your function involves any kind of integers and integers to integers. I had plenty of off-by-one errors or using the wrong integers, etc. And OCaml the type system did not help me there, and usual testing did. So yes, it was hell to debug, even though I ported it from OCaml. It took me like 2 or 3 weeks to port it, but then it was working better than it used to OCaml in half the code and with more functionality. So yes, and making the thing persistent is just 70 lines. And you say, but you need the persistent infrastructure, which is also a few hundred lines. So for instance, content addressing is 160 lines, and DBQ is 170 lines, and DB is 300 lines. Okay, so I have maybe a bit under 1,000 lines of code. as a general infrastructure to make things persistent in general, but the part to make this particular data structure persistent is just 70 lines of extra, 70 extra lines of code for this particular data structure, which I believe is pretty good, including a part just to compute Merkle proofs. So this is additional functionality, which is taking half the size of the file. So really, the part that makes the tree persistent is that where's the wrapper? There's something about the wrapper here. Digest from bytes, and there should be something else about tracking. I don't remember, but what else did I want to discuss before we close? I want to disclose types. Ooh, types. If you want to put that in Haskell, you have a bad surprise. You can do it. And objects, so .hs. Here's the same thing in Haskell. Problem in Haskell, what you really want in a prototype is something that takes the self and the super and returns the self, where self, the type for self would be a subtype of the type of super. Bad surprise in Haskell, the only usable subtype you can have is itself. So basically all your prototypes are monomorphic. So you can have the prototypes for functions from number to number, or functions from field to a dynamic type, or from field to every field has the same value, which is not as useful. So yes, you can define, all those functions are defined, but it's very monomorphic. And in a way, if what you're doing is classes, the only type you need is class descriptor. So you could have this for where the function is class descriptor and your mixins or mixins for class descriptor, everything is a class descriptor. It kind of sucks, but it does the thing, and you still need some kind of reflection principle in the end to have or dependent types to have to represent classes as class descriptor using inheritance. But you could do that. But this monomorphic aspect to this construction means that this does not work with your regular type languages. You either need full-on dependent types or you want dynamic types, but weak, not weak, poor static types. And Haskell has the richest static types in all the usable programming languages, and even that is not enough. You need full-on dependent types if you want to deal with classes as first-class prototypes, which is one of the things that makes prototype.
Have you thought about how to implement dependent types with your prototype? Not yet. It's an open problem.
Yeah, it's
okay.
So much open that a lot of work.
Okay, this is the homework assignment for everybody on the list. You have to figure out how to do dependent types with prototypes. So
yes, yeah.
We'll leave that as an exercise to the reader.
Yes, left as an exercise for the reader. Yes, it's not conceptually hard, but it's a lot of effing work. So
yeah.
Another thing that in the future I would like to add more things such as a mob style, class style mob, and I have a project for that, and also method combinations. And another thing is that right now what we have is inheritance lists. Inheritance lists is cool if you are going to curate those inheritance lists yourself, but what you really want is, like in class, that this inheritance list is actually a linearized version of the inheritance DAG. So you don't have to manually remove or order your super things, and you can have things that depends on an upper object for super, and and you want your specification to commute the right way. You really want a DAG. You don't want you don't want to do this list by hand. And the problem with the JSONet model, the mixed model, and the model of proof. Yes, my daughter is shouting about something. The problem with we really want an intern data, like direct direct superclass, direct super prototypes, etc. And that's not right now in poo. I want then to be able to generate multiple aspects of a poo from other aspects. But wait, I need to deal with my daughter. Hey, yes, little daughter. This is. You want a sipping gummy? Have you had dinner? Do you want to sip now? If you want to sip now, take the sipping gummy now. If you don't want to sip now, don't take the sipping gummy now. Okay, so yeah. So
questions on YouTube, just type them in and I'll read them out.
Yes.
Anyways, continue.
There are plenty of things I would like to do with prototypes that require extra codings that I don't have time for now. Of course, if you want to do everything efficient, we want a partial evaluator, etc., etc. Infinite projects are possible based on that. And yeah, and I think now is question. Yeah, little Leonora likes to type stuff. Thank you, Leonora, for your contribution to this article. I appreciate. And now other questions from YouTube. If you can read the questions you want me to answer. I don't know if I'm on YouTube.
Yeah.
But...
Or on the list here with the audience. Any questions?
First from the audience, and then I'll take questions from YouTube.
By the way, it wouldn't be a LispNYC talk. Wouldn't be a LispNYC talk unless your daughter participated. So
yes,
I think she's participated in every one that you've been in. So.
No, this is another daughter. The daughter that used to participate was. This is Leonora. She was too young. Back when I was in New York, she was too young to participate, but now she's old enough. And yes, if you want to participate, type in this. Type at the scheme prompt. You're a Lisper, Leonora. Don't type in my document. You want to type at the scheme prompt. Yes, this is good scheme code. And the variable psxs. Oh, well, I don't know what you did, but. Yeah, these variables are not bound, so this will not result in a very useful result. But you could do things. Do you want to add two numbers, Leonora? Yeah. You can do plus and type two numbers. It will compute the sum.
1 and 4.
You need to put a space between 1 and 4, and then you need to close the parent and press enter. And what is the result? What result did it say?
5.
5. That is correct, Leonora. That is correct.
Again.
It's important to get people into Lisp as young as possible.
Yes. Okay. So what else can I show you? Or are there questions that I need to answer? Anyone in the audience, please ask questions.
Yeah, go for it. Make sure you click your mute button, because if you're muted, then no one can hear you.
Is this all posted somewhere? This directory you keep showing us tantalizingly?
So this document is not published yet, but it will be published shortly. The code is public, like a Gerbil.
Yeah, and I actually have it on the description of the meetup, as well as the description on the video.
Oh, great.
A link to the project.
Yes, and we will add a link to this file when this file is published somewhere. I will probably put this file in the Gerbil poo directory itself. Leonora, and I will probably keep working on it so that at some point I have something good. No, don't edit this file, please, Leonora. Please edit your command line here. You can,
again.
What?
Again.
Okay, you can type the same computation or different computation again. Other questions?
Fari, you showed us some NixOS configuration files before, and I noticed that Nix has been mentioned a couple times on the Gerbil scheme as the ease of building stuff. But have you done any work in generating Nix configuration with Gerbil scheme?
No, I've done Nix by hand and using Nix and Nix's built-in prototype object system. I have not so far generated Nix from scheme, although I have some programs that use Nix from. So if I look at, for instance, Gerbil util/scripts, you can see something. Update Gerbil Nix recipe. I have a script written in in Gerbil scheme that will indeed update all my files in mixed with the proper versions. So when I push the little girl and I put her upside down, I don't know if you can see that. Maybe I should put you down, but not after I tickle you. Okay.
Speaking of which, actually, there is an operating system that more or less does that. I mean, it's its own thing, but it's called Geeks. It's spelled G-U-I-X,
which sucks if you hate if you hate open source. It sucks. Sorry, and Guile sucks too. But anyways.
Well, yeah, I do have a problem with it in the sense that it's if you want to kind of stray outside of the pure free software, it's kind of difficult, which is unfortunate.
No, actually, it imports NIX packages so good.
Okay.
That when I did use GUIX, I imported all my packages from NIX because GUIX wouldn't work.
Oh, that's an interesting question. So maybe someone could port Poo to Guile and make it success so that we can have a prototype object system just like in Nix to configure.
A really annoying fact that I hate, but it bit me in the butt a while back, is that in R6RS systems like Guile, but Racket apparently doesn't enforce it, you cannot begin an identifier with period.
Oh,
what Commonlist calls a potential number, and it doesn't work.
Okay, well, here it worked in Gambit and Gerbil. So
yeah. Well, as far as I know, Gambit is not R6RS, is it?
It strives to be R7RS these days, but I don't know if it has
R5.
It's R5, yeah.
I think it's R5.
Specifically, R6RS systems will not do this because they don't like identifiers beginning with periods.
Yes.
Because if an identifier begins with period, and it has letters in it afterwards, how do you know it's not a 36 or a base 36 fraction, right?
Yeah, the rule R6RS adopted was if it begins with something that could be the beginning of a number, then that's all then we assume it's a number, and then we fail because it's not a number.
Yeah, I mean, Common Lisp made somewhat that decision as well.
Yeah, with the potential numbers, exactly.
Yeah, but it's not as restrictive.
Yeah, whereas in R7, the rule is if it has a prefix that really is a number, which is not true of .o, then that's no good. You cannot have 7 APC. That's not a number.
Yeah,
or even 7 PQR.
But like, what if you are doing like a 36, base 36 fraction?
Well, then it still has to have something in front of it indicating base 36. In Scheme, that is. Scheme doesn't have.
There's no default radix.
There's no. Yeah, you can't change the input radix.
Mm-hmm.
Yeah.
Changeable radix. Yeah.
Okay. Okay, little girl, what? Maybe Vera wants to say something to her friends at LispNYC. Hey, Vera, do you want to say hello to LispNYC? Vera, say hello to your friend at LispNYC. So this is Vera who used to participate to our meeting.
That's the one I've met.
Yes.
She was the youngest presenter at LispNYC ever, right?
Yes, she was the youngest presenter, and now she can present you her acrobatics. Oh, Sylvie is crying. Sylvie is crying. That's okay. Oh, poor Sylvie. Okay, let's go back. I don't. Okay, so don't know if you have other questions. If you don't have questions, we can wrap it up. But if you have more questions, I will be. And the code is the code. The code is
in the description.
Yes, and the presentation or the notes I had for the presentation will be committed to the repository soonish, and I will probably clean it up and put it tonight.
Yeah.
And You want the headphone? Okay. Maybe I should disable headphone somewhere, but that's okay.
Okay, so I guess if there's no more questions, let me close out. Let me have a little message to YouTube. Remember
Okay.
to like this video because it was awesome. Great speech, by the way. So like the video.
Thank you.
Subscribe to the channel so you can get other videos.
Say something, Leonora.
And share it to all your socials.
I can't hear you guys, but Leonora can now.
Yeah, I know.
If you want more
Say hello
information
to
on how to
Arthur and
become part of
LispNYC.
the this event,
Where you can say hello
the,
to
chat,
Arthur and
you can
LispNYC.
go to lispNYC. That is
Give
our
that,
main
give that
website.
back to me. Okay.
I
Well,
wrote my
goodbye. I'm
phone
leaving now.
next to you.
Yeah,
Okay.
exactly. So we're
Bye,
going to
bye,
close the parentheses, and meanwhile, we're going to just hang out and chat a little more and ask more questions to the speaker. Thank you very much for joining us. See you when I see you.
If you have question, I may still be there, but
For a little bit. But anyways, okay, we're closing the parentheses. Got it.